until now, I finished what I want to say in this lecture. If we have any problem, any question, anything, just let me know. Next time, I'm going to talk about fundamental solutions. I will cover something like 80% of the fundamental solution. So I think Professor Fu changed his place or something like this. Right?
No, I'm in the same place, but my computer is no battery, so I changed to my cell phone.
Okay.
Yeah. Yeah.
Actually, here I have very plan B problem. I have 2 internet connections, and I have battery, and I have mains, electric mains. So I have a lot of things. Even if we have electricity cut off, we will carry out the lecture.
Yeah. So could you move to the 32, page 32? I think I have some more things to talking about. I think it's the next page. Yeah.
Okay.
As you mentioned, yeah, for the deal within the singularity, I think there's some. I think that there's some famous person in China. They do this related work, like you mentioned using the nonlinear coordinate transformation. I think the Professor Yao Ming Zhang, he did a lot of this kind of research.
Right.
And as you mentioned, using the Tyler expansion formulation, I think the Professor Zhongrong Niu, maybe you may meet them. Zhongrong Niu, Professor Niu.
No.
Yeah, Niu. Yeah, they did a lot of the work in this area. Maybe later I can send you some paper.
Sure. But let me tell you something.
Yeah.
If we concentrate only on singularity isolation using Taylor expansion, it is universal method. You can deal with
that's
anything.
powerful.
You can deal with anything, but you need first to understand what is meaning by Cauchy principal value, Hadamard finite part. Because of that, what we need first is to cover fundamental solution, understand it, and actually is not to cover fundamental solution. We need to cover how to decompose any fundamental solution in terms of potential. This is Newtonian potential, actually. Okay? Then we need to understand what is meaning by transformation of domain integral to the boundary. These are main points in boundary elements. After that, we will understand how to deal with what is meaning by Cauchy principal value, how to weaken the singularity using integration by parts or applying green identity or transfer domain integral to the boundary. Like what we do in 3-dimensional problems. If we change our integrals to the boundary of the element, we weaken the singularity, actually. Okay? We avoid singularity. Okay? Then we talk about singularity using versatile method. I have tried several things. Nonlinear coordinate transformation, analytical integration. The best thing really is universal and can, we look to have systematic way in boundary elements. What makes boundary element difficult is people or researchers change it to mathematical method. I don't want to put it in a mathematical method. I want to do it in application method, in engineering way. So we want to give to researchers techniques, universal techniques. Once you face something, you will use this technique. Once you face something, you will use this technique. I believe, and you will see, with this Taylor expansion, you can attack any singular integral. But I like also to see other techniques. I like to see other techniques. I always open for new methods, and we can join methods together. This is our role as researchers. Okay. Any other question?
So I think anyone has a question? Yeah.
So I don't think there is a question now.
Okay, so
we'll see you next week.
Yeah, if no, see you next week.
Okay. Yeah. So thank you, everybody.
Okay.
I will see you next week. Any question during the week, I am ready to reply on WhatsApp or WeChat. Okay?
Okay.
And I will be waiting for your email, Professor Fu.
Yeah, of course.
Okay.
Later I will send you the emails. Yeah, okay.
Bye now.
Yeah.
Bye.
So bye. Have a nice day. Yeah. Bye-bye.